Hi everyone, this is the third video for section 9.2, solving equations using rational numbers. So in this video, we're just going to go through some examples of working equations. So again, these are all things you should know from college algebra, but we're going to go through it just in case. And the main part of doing this is because we're going to show every step and justify every step. So as I'm sure you're aware of by this point in the course, a lot of the point of this course is to show why you can do the math things that we learn. And so justifying each step is a really big part of doing that and a really big part of getting credit on exams and things of that nature. So the first equation we have is c over 5.3 plus 8.3 equals 11.3. So we're going to start with our equation. C over 5.3 plus 8.3 equals 11.3. And so the first thing that I would do is subtract 8.3 from both sides. You can do this by writing it underneath. I like to do it on the sides. I know that's not common, but we subtract 8.3 from each side. And this, because I like to write it on the sides like this is a really good point to note that on the left, we're adding negative 8.3. And on the right, we're subtracting 8.3, but we know that those are the same things based off of our properties of multiplication with integers. So here we are subtracting 8.3 from both sides. And then when we rewrite this, we get c over 5.3 equals, should just be 5, right? 3. That is definitely not 5. That's 3. Okay, so then what we want to do is we want to multiply both sides by 5.3. So we multiply 5.3. We multiply both sides by 5.3, and I'm sure as you can tell, I'm doing the reverse order of operations because I'm subtracting and then multiplying. So on the right here, we get c equals, and then 3 times 5.3 is 15.9. So you may need to do some scratch work, considering that we still don't have calculators. That has not changed. So you may need to do some scratch work on the side. Okay, and that's all there is to that one. So the next one. So we have 4/5 minus 2g equals 1/10. So this one is a little bit more complicated with the fractions. So we start out, I'm going to write it over here. 4/5 minus 2g equals 1/10. And so the first thing that we can do really anything we want to, but since this one's dealing with more complicated fractions, I'm just going to start off by clearing the denominators. So I'm going to multiply by 10. Remember, you need to put parentheses if you're multiplying by this entire side. So I'm going to start off by multiplying both sides by 10. Okay, and remember that we need to distribute here on the left side. So we get 10 times 4/5 minus 10 times 2g equals 1. So I'm going to simplify this. So 10 times 4/5 is 40 divided by 5, which is 8 minus 20g equals 1. Okay, so next I'm going to subtract 8 from both sides. So again, I'm using this. Subtracting 8 is the same as adding negative 8. So we're going to subtract 8 from both sides, and then we get negative 20g equals negative 7. And then lastly, we are going to divide by negative 7. So we get, divide. Why are we divided by negative 7? We should be dividing by negative 20 to get g by itself. So we are going to divide both sides by negative 20. And we should get G equals 7/20. Okay, so that is what we get. So one thing that I want to note here, whenever I'm writing my justification on the side, you'll notice that there's a difference in the way that we talk about addition and subtraction versus multiplication and division. So whenever we talk about subtracting, we're subtracting from both sides, and then we're multiplying both sides. And that same thing holds with division and addition. We're going to subtract from both sides, we're going to add to both sides, and then we're going to multiply both sides by and divide both sides by. So just one thing to note whenever you're writing these things down, just in the way these operations are defined, that we divide and multiply both sides by something, but we add to both sides and subtract from both sides. Just notice how it's written here. Okay, so we have one more example of solving equations. So we're going to assume we have twice as many bus tokens as one of our colleagues, and we give our colleagues several of our tokens so that now we have 120 each. And we want to know how many bus tokens we gave him. And so to do this, we really need to know how many each of us started with. So let's reason it out. So each of you now has 120 bus tokens. So since we each have 120 tokens, there are 240 tokens total, since we both have 120. So we can work backwards to make two groups where one has twice as many tokens as the other. So we work backwards to find two groups where one group, this should be TW. So we work backwards to find two groups that add to 240, where one group is twice the other group. So there's a lot of different ways to do this, actually. If we were in a college algebra class, you would set up a system of equations and solve it. But we're doing elementary analysis, right? We don't deal with that kind of things that complicated. So what we're going to do is I'm going to split 240 into two groups. And I want to change these groups slightly so that one of them is twice the other. So that means that these two are equal. So in order for one of the groups to be twice as big as the other group, that means we need to make one bigger and one smaller. So we can do that in the following way. We can go from 120, we can add 10 to get 130 and subtract 10 to get 110. So to go from here to here, we add a 10. To go from here to here, we subtract a 10. And you'll notice that now we have a group of 130 and a group of 110. So these still add to 240, but now there's a difference of 20 between them. And so we can keep going. We go from 130 to 140 and 110 to 100. And then these 100 times 2 is 200, so this still isn't quite right. So we can go to 150 and 90. 90 times 2 is 180, so it's still not quite right. Then we can go to 160 and 80. And 80 times 2 is 160. So these two groups have the property that 160 plus 80 is 240. And 80 times 2 is 160. So these groups satisfy the properties that we want. So what does that tell us about this problem? It says that I started with 160 tokens, and my colleague, you can also rewrite, I started over here. So I started with 160 tokens, and my colleague started with 80. And then we know if we both had 120, that means that I gave them 40 tokens, because 160 minus 40 is the same as 80 plus 40, which is 120. Great. So we gave them 40 tokens. So, like I said, if we were in a college algebra class, we would set up a system of equations and solve it. But you can also do it this way. So these are problems that are really, they're really accessible to students, even though they may seem difficult at first. If you went to high school in Texas and you have any experience with UIL competitions, these are a lot of problems that would be on competitions of that sort in schools, or things like this that are really accessible to younger students, but that just require clever thinking of this sort to kind of get through it. So the book also talks about one-step versus two-step equations. We didn't really make that distinction. We just solved the equations, right? We all know how to do that. So that's going to be it for this section, and that's it for this video.